Hello again, gang. So we're going to do the teacher station video for surface area of prisms. This is for stop 6 in geometry. Okay, so surface area of prisms. Hello. So congratulations. Why do you need to know this? This is a real world kind of a problem. Congratulations, you've just been hired as the new product manager, the production manager of a popular candy, Dandy Candies. You want to impress your new boss with some money-saving tips, and the cost of making the candy is not negotiable, but you might be able to save some money on packaging. So let's consider the following. And I'm going to watch this little video. Pay close attention. It's going to be a lot of fun. Okay. So, did you follow that along? Okay. Rank these packages in order of which one uses the most cardboard to the least. So which one of these uses the most cardboard? I'm not going to work through those, so I want you to just think about it. You can pause the video and think about it. So question 1, rank the packages in order of which uses the most to the least. Number 2, rank these packages in order of which uses the most ribbon to the least. So cardboard and ribbon contribute to the cost of the packaging. Number 3, how many candies do you think they were trying to package? How many candies do you think are going, do you remember from the video? How many candies do you think we were trying to package? In each one of these packages, the number of candies going inside is the same. How many were in there? And what do you think, number 4, what do you think are the dimensions of each of those 4 packages? You can pause the video now and go do some calculations. Welcome back. I hope you paused and you went back and took a look at the video because on the next chart, I was supposed to play the video again, but just to save space on my video creation, I'm not going to play it again. You can go back and play it again. So the things to watch for are there are 24 candies in the package. And this time, pay attention to the dimensions of each package. You know, how many candies wide, how many deep. And is the volume the same or different for each box? Good question. Remember how to do the volume of a pyramid? I mean, the volume of a prism? These are all going to be rectangular prisms. Okay. Now, using the dimensions below, rank the boxes again in order from which uses the most cardboard to the least, and use math to justify your answer. So now we're actually giving you the length, width, and height in candy units for each one of these packages. So go and determine which one uses the most cardboard to the least. again, I'm not going to work this problem out here. This is for you to play with. So pause the video, go get a scrap paper, and try to put them in order from greatest to least. Okay, welcome back. I hope you got some calculations done, and I'm going to move on. So let's go ahead and figure out. So in order to, what you're calculating here is you're calculating the surface area of the cardboard. In order to rank the boxes, you had to find that area for each side of the box and then add them all together. This is what surface area is. Each box is considered a rectangular prism. And how many sides will a rectangular prism always have? So think about it. If we have a rectangular prism, there's going to be 4 faces that represent the height, so each one a rectangular, and then 2 bases, so 4 plus 2 is 6. It's always going to have 6 sides. Okay. Are they going to have the same area every time? When you did your calculations, you should have found out that different size boxes, different size packaging will have a different size of area. Okay, surface area. All right, so it's sometimes easier to draw a picture by deconstructing the 3-dimensional prism into a 2-dimensional composite figure. Okay, so here's a 3-dimensional view. Where's my neat little thing? So we have length, width, and height of our rectangular prism. And if we were to slice down the edges and open that up into a flat piece of cardboard, for example, we would have a side that is width times height. And we would have another side right here that is also width times height. Then we would have a back and a front that are height times length. And we would have a bottom that's length times width and a top that's length times width. And so let's count them. 1, 2, 3, 4, 5, 6 sides that you have to take into consideration. Okay? Side, side, back, front, bottom, top. So that would be side, side, back, back, front, and top and bottom. Okay. So we like to do this in a very structured way. We'll set up a little table for ourselves for top and bottom, because those are going to be the same. Front and back, those are going to be the same, and side and side. So this is our 6 sides. And so the total surface area is the sum of all 6 of those sides. So that's one kind of surface area. Then if we were going to do something called just the lateral surface area, the lateral surface area is the area without the top and the bottom. This is the 4 sides, not including the bases. So the base of this square or this rectangular rectangular prism, this is the top and this is the bottom. So the lateral surface area would be the other 4 sides. Okay. So we'll ask you to calculate those in different problems. Okay, so find the surface area of this. What is this? This is a rectangular prism. Okay, so we have a top and a bottom, a side, and a back and a front. Okay, let's calculate. So first of all, let me switch cameras so you can see my whiteboard. Here we go. So top and bottom. Top and bottom. So the top and the bottom are these 2 surfaces right here. So this will be the top and this will be the bottom. These are actually the bases of our rectangle. So the one side is 7 meters and the other side is 4 meters. So I have 2 of them, so I'm going to say they're both the same. 2 times 7 times 4. And 7 times 4 would be 28, and 2 times 28 would be 56. 56 meters squared. Okay, now I have a front and a back. Front and a back. So the front and the back are this face and this face back here. So this face and this face. And my dimensions for that are 4 meters wide and 8 meters tall. 4 meters, so this face right here, 4 meters wide, 8 meters tall. So I have 2 of them. So I'm going to say 2 times 4 times 8. 4 times 8 is 32. Times 2 would be 64, and it's meters squared. And then I have a side and a side. And so my sides are this side right here and this side right here. And so this side is 7 meters by 8 meters. And there are 2 of them. So I'm going to say 2 times 7 times 8. 7 times 8 is 56. Times 2 would be 112. And that's meters squared. And now all I have to do to get my total surface area is I add those 3 numbers together. So 6 plus 4 is 10, plus 2 is 12, carry the 1. 5 plus 1 is 6, plus 6 is 12, plus 1 is 13, carry the 1. 1 and 1 is 2. So 232 square meters. This is my total surface area equals 232 square meters. Okay? Now lateral surface area is the surface area not including the top and the bottom. So not including our bases. So remember we said our top and our bottom was this side and this side. So we're just going to subtract 56. So 232 minus 56, or you can do 64 plus 112. That's probably easier. 64 plus 112 is 176. 176 square meters. So that's lateral surface area. Okay, so that's all of the sides, not including the top and the bottom. Okay, piece of cake. Surface area. Okay. Hello. How about this one? Let's find the surface area of this shape right here. Remember, we have our top and our bottom. So our top is this piece right here, and our bottom is the opposite side. Okay? So that's the hardest part of doing these total surface area and lateral surface area problems, is deciding at the beginning which one is the top and the bottom. Okay, but if you're consistent, it's always going to work the same way. All right, so top and bottom. My top is, I have 2 of them. 9.5 inches, so 9.5 times 3 inches. Okay, so 9.5 times 3, that would be 27, 28.5 times 2, so that would be 56, that would be 57, and we have inches squared. 57 square inches. Now I have a front and a back. So my front and back are these skinny ones. That's the front and that's the back. Front and back, front and back. Okay, so the little skinny ones, I have 2 of them. And those are 9.5. And they're little skinny ones, so 1.5 inches tall. So 1.5. Okay, I can't do that one in my head. So 9.5 times 1.5. 5 and 5 is 25. 5 times 9 is 45 plus 2 is 47. Start with 0. 1 times 5 is 5. 1 times 9 is 9. And I add 5, 7, and 13. And there are 2 decimal places, so my decimal point goes right there. So 13.75 square inches. And then I have my 2 sides. And my 2 sides are these little guys right here, the opposite sides. Okay, 3 by 1.5. So I have 2 of those, 2, and one dimension is 3 inches, and the other one is 1.5. So 3 times 1.5 is 4.5. Times 2 would be not. Oh, I forgot to multiply this one by 2. Oops. 26.75. That would be. Sorry, 13.75. That would be 27.5 multiplied by 2. Sorry about that. Okay, now on this one I have 3 times 1.5 is 4.5. Times 2 would be 9. So 9 square inches. Now, total surface area, I add them all together. So 57 plus 27.5 plus 9. So I have 0.5. Remember, the decimal point comes straight down. 7 and 7 is 14, plus 9 is 23. Carry the 2. And I have 5 and 2 is 7, plus 2 is 9. So 93.5 square inches. Okay, remember we're doing area, so our units are squared. And we said for lateral surface area, it's everything except for the top and bottom. So I would just add the front and back and side and side. So 27.5 plus 9 would be 36.5 square inches. Okay, let's take a look at this drawing again. So the most difficult part of differentiating between total surface area and lateral surface area is deciding which is the top and the bottom. So I said if you're consistent, it'll always work out the same way. And to be consistent, think of the top and the bottom. Think of the bottom as the surface that the shape is actually sitting on. So if this object were sitting on a table, this surface down here, let me see if I can try to highlight it. So this surface right here would be the surface that's sitting on the table. Okay, so that would be the bottom. And the opposite surface would be the top. So this surface up here. Okay, so this would be the top, and this surface down here at the bottom. And if you always do it that way, you'll always be consistent, and you'll get the same answer, or you'll get the right answer every time. Let me erase this. Okay, so back to my special little highlighter. Okay, let's look at the next one. What about triangular prisms? So do we have the same number of sides? Do we have a top and a bottom, a side to side, and a left or a front and back? Well, no. So how many sides do we have on our triangular prism? Well, let's see if I can highlight a little bit. Okay, here we have a base, and the opposite side is another base. And both of those are triangles. So this is our triangular base, okay? And when we do our total surface area and our lateral surface area, the sides that you are going to subtract from your total surface area are the bases, okay? So they'll be the triangular shapes, okay? And then we are left with 3 other sides. So we have this side back here. So this side back here. So try to highlight that. And then we have this side down here in the bottom. So this guy, it's really hard to do three-dimensionally. And then we have this very large side right up here. Okay, so we have two bases, base. Those are triangles. So there's two. And then we have three other faces. The back, the face that's laying flat on the table here, and then the sloped face. Okay, so three other faces. All right, so that's 1, 2, 3, 4, 5. 5 faces. How many sides do you need to consider? 5. What would the net look like? So if we were to unroll this and try to make a net picture out of it, okay, so it would have 2 triangles and then 1, 2, 3 rectangles, right? Are any of these sides the same? Well, maybe if the triangle is isosceles, then some of the sides would be the same, but not always. You can't count on that. All right, let's take a look. Let's erase first. Now let's take a look. Okay, here's what the net picture would look like. So this side right here would be this back part. So I just do 3 lines on him. This big face in the middle would be probably maybe this face. I do 4 lines on him. So 1, 2, 3, 4. And then we have this bottom face, which just has kind of a squiggle on it, and the 2 triangles. Okay, so that's what the net would look like. Okay, let's do some calculations. Top and bottom of the triangular bases, and then side 1, side 2, side 3. So you can't assume that they're all the same unless you're very careful and you notice that there are equal sides and equal lengths, and maybe you can do it, do a shortcut. But I'm going to recommend to you that you always break it out and do 3 sides separately so that you can keep track of it. All right, so we're going to have a top and a bottom. Those are going to be the same because it is a prism. So the triangles is the triangle shape is the same all the way through the prism. And we know that there are 2 of them. So I'm going to start out by 2. And so the area of a triangle is 1/2 base times height. So 2 times 1/2 is 1. So I'm just going to put my 1/2 there, and we'll cancel those out. And base times height, my base is 12 yards. Base is 12 yards, and my height is 5 yards. So 5 times 12, 5 times 12. So 2 times 1/2 is 1. 5 times 12 is 60. So my top and bottom are 60, and it's square yards. Okay, now I have side 1, and you can count them in any order that you want. I'm going to take, first of all, this back rectangle that goes here. All right, and so it is 10 yards long and 5 yards high. So it's a rectangle, and there's only one of them, so it's 5 times 10, and that is 50 square yards. Okay, then I have this rectangle right here, which is the sloped one. So it is a rectangle that's 13 yards by 10 yards. So 13 times 10, and that's 130 square yards. And lastly, my third side is the one that's flat on the table, and that one is 12 yards by 10 yards. Okay, be very careful. So 12 by 10. So 12 times 10 is 120 square yards. And so my total surface area is all of those added together. So 50 and 60 is 110, plus 120 is 230, plus 130 is 390. 360. So 6 and 5 is 11, 24, 36. So 360 square yards. So that's my total, 360. And my lateral surface area is everything except for the top and the bottom, which are the bases. So the bases were 60. I'm just going to subtract 60 off of my total, and that means that my lateral surface area is 300 square yards. Okay? That's how you work those problems. I really suggest, I'm going to look you in the eye now. I really suggest break them out and do them separately to keep track, to make sure you get all of the areas. Okay, don't try to take shortcuts on this, folks. All right, let's find the surface area of this triangular prism. Find the surface area, top and bottom, side, side, side. So my top and bottom are always going to be the same because they're prisms. And so my triangular base, there are two of them. And the area of my base is 1/2 times. And then I have base is 6. And the height of my triangle is this dimension right here, 5.2. So 6 times 5.2. All right, and so 6 times 5 is 30, plus 1.2 is 31.2. Is that right? Let's just multiply that. 5.2 times 6, 12. There's the 1. 30, 31.2. Okay, so that equals 31.2, and my dimensions are centimeters, so centimeters squared. All right. Now I have side 1, 2, and 3. Let's take side 1 as being the guy in the back. So it's this one right here, this back rectangle. It's 6 centimeters wide and 10 centimeters tall. Okay, so 6 times 10 is 60 centimeters. All right, side number 2. This guy right here. He's 10 centimeters tall by 6 centimeters wide. So he's also 6 by 10. And so we'll call him 60 centimeters squared. And lastly, I have this rectangle right here. 6 centimeters wide and 10 centimeters tall. Okay, so he's also 6 by 10. So 60 centimeters. Okay, so my total surface area, 60 times 3 is 180, plus 31, so that would be 211.2 centimeters squared. So my total surface area, 211.2 centimeters squared. And my lateral surface area is just these 3 sides. Wow, I forgot that I wasn't showing you my whiteboard. Let's click over here so you can see the whiteboard. So my total surface area is the sum of all 4 of them, my 3 sides plus my top and bottom. And that came out to 211.2 centimeters squared. And my lateral surface area is just these 3 sides, or 180 centimeters squared. Okay, just remember, I did a shortcut and I said 2 times 1/2 is 1. So then I just had to multiply 6 times 5.2. And that gave me 31.2. Okay? If you write it down step by step, you can see some of these shortcuts that you can take to make your life a little bit easier. Okay. Let's see, is there one more? Yep, there's one more. Let's find the surface area of this triangular prism. Okay, top and bottom are triangles. There are 2 of them. So 2 times 1/2. And the base. So this one you got to look at a little bit more carefully. Remember, our height of our triangle is the measurement that's perpendicular to the base. So our base is not 5. That would be the sloped one if it was standing on either the 4 edge or the 3 edge. Okay, so look carefully. Where is the measurement that's perpendicular to one of the sides? That would be your base and your height. So I'm going to use base is 4 and my height is 3. Okay, so that gives me 2 times 1/2 is 1 times 4 times 3. So that equals 12. And my units are centimeters squared. Now I have 3 sides. Side 1, side 2, side 3. So the first side, this edge times the length. So I have this edge is 3 and my height of my prism is 8. So 3 times 8. And 3 times 8 is 24 centimeters squared. Side 2. Let's go with this face right here. So this side, this edge right here is 4 centimeters. And the height is 8. So 4 times 8. 4 times 8. And that's 32 centimeters squared. And the last side would be this surface right here in the bottom that it's sitting on flat. And so that edge is 5 centimeters by 8 centimeters. 5 by 8. Okay, 5 times 8. So that's 40 centimeters squared. And so for total surface area, I add all 3 together. So 40 plus 32 is 72, plus 24 is 96, plus 12 is 108. 108 square centimeters. And my lateral surface area is the 3 sides without the top and the bottom. So 40 plus 32 is 72, plus 24 is 96. 96 centimeters squared. Okay, there you have it. I think that's the last one. Yep, on our next video, we're going to take a look at the surface area of pyramids. So, until then, I'll see you.